So with what order are we doing the problems in?
We should do 1, 4, 2, 5, 6, right?
Oh, 1 second.
1, 2, 3, 4, 5, 6, or do we do 1, 4, 2,
Yes,
5?
yes, 1, 4.
We look at problems in this. Okay, it's live. I think we are live.
Okay, can
Interesting.
someone check from YouTube?
I'll check. Yes, we are indeed live. Okay, great. So hello everyone. I'm Atul. Arshit, can you introduce yourself?
I'm Archit.
I'm done.
I'm Siddharth.
Yes, so we're going to basically try the EGMO paper, and obviously we have not seen any of these problems before. We're just going to try it now and see how it goes. We'll try this for up to 3 hours. Whatever we solve, we solve. If we think we're close, we might extend it. That's about it. Okay, so we have not seen the problems before, so let's see. Do you want to see day 1 or day 2 first?
Let's start with day 1 only.
Day one.
Yeah.
Why random stuff? Okay.
TO is P2. What is P? P3 combo and not grid. Oh, okay, it's a grid.
Grid and string combo, which is sad.
String combo. Yes. Problem 2 looks interesting.
Shouldn't we do P1 first?
Wait, isn't problem 2 just from the Sophie and Momox? Like, I'm fairly
No
sure.
idea. Let's start with people.
No.
Yes. Is it not the same?
No, what the hell? How is this the same?
I mean, it's the idea is the same. Like in this, you introduce the antipode and then you solve it.
Oh yes, I remember this something similar to this in the Sophie and Walk. One of them.
Yeah, it looks like the same, no? Because angles
Yeah.
are also.
Hmm.
Okay, interesting.
Okay.
I guess we'll get to that. Okay, next day 2, I guess we can see. Turbo
Oh my God, Turbo the snail.
Turbo the
Oh my
snail.
God.
They
Oh
should
my
die
God.
them in a combo problem.
Turbo. Oh my God. Brings back bad memories.
Wow. Turbo returns to EGMO after 2017-3.
Yes.
What is P5? The twist. Interesting. Huh, okay. Okay, P6. Okay, this is probably hard. SVS. Wait, INA intersection ABC is just mixed linear touch point. And you have midpoints of Rx. Maybe this is not that bad. Okay, anyway. Which problem do we begin with? That's problem 1 or something?
P1.
Okay.
P1.
I'll zoom in a bit.
Hmm.
Just a second. I'll put this in the Miro code. Ah, okay. I don't have it already written.
I wrote that like just 2 seconds.
Hmm. No. This is the problem.
What happens when you have 3 increasing?
What happens if
AI less than AI minus 1 less than equal to AI less than equal to AI plus 1.
AI minus 1 less than equal?
Because like AI 3 increasing, AI minus 1, AI and AI plus 1 are increasing.
I see. That's not that useful. Like if AI was not in between, then that's nice.
Yeah, it's peak
Yeah.
up or peak down, it's better.
Huh. Okay. What if we have
If it's peak up, then BI is at most 2.
No, just check when is BI at most BI plus 1. That should already give us a lot of information. Like, what is this? Rewrite it. It should not be that bad.
also if AI is greater than equal AI minus 1, AI plus 1?
See, first we should probably replace BI with like BI plus 1 because that gives a more global sum on the top, right? It's 3 consecutive terms.
But the denominator is
Or what we can do is probably
It's like middle grade.
differences. Right, and then this becomes AI plus 1 minus AI.
Wait, this is also sort of weird, no? Because AI is smaller
Large is
than
small.
stuff, then BI is big, but it's telling us to assume this, that AI and BI are in the same order of increasingness. Something.
Imagine we just use Chebyshev or something and then instant equality everywhere.
How do you do check? Okay, you do have AI, BI stuff. But... Wait, what if you just pick like AI maximum?
And AI minimum. Their neighbors must be equal.
Yes. So
And
like
then you
if, yeah.
What?
Okay, wait, let's just check that this works. So if, let's say, AI is
No, wait. Yeah.
maximum,
And the count is in there.
then BI is clearly less than equal to. And if AJ is minimum, then BJ is greater than equal. Oh, actually, we don't even need to repeat anything, right? Like we know that
You need to, right? You only get AI is AI minus 1 and AI plus 1.
no, like you get this implies that AI, we know AI is at least AJ, right? Because maximum.
Yes.
But this should imply BI is also at least BJ. But this is at most 2, this is at least 2.
Equality,
Okay,
equality must hold there as
Get
well. Because,
equality hold.
yeah, okay.
Equality
So
holding just gives neighbors are equal.
this means AI minus 1, AI plus 1 maximum also. And actually, we don't even need to bother with the minimum.
and then you can just
We can
keep
spread
spreading
them
this out and eventually they'll reach a common point, right? If you have
Yes.
something like this is minimum, then stuff
Yeah.
around minimum is equal to minimum. And
Yeah,
then
you
just
don't even
keep
need to
spreading.
spread out both of them. Just fix minimum and spread out the max. Everything becomes equal to the max.
Yeah.
And if everything is equal to the max, then all AI equal, so all BI equal.
Yeah.
Okay, that's nice. I guess we can, for anyone watching, we can just repeat the solution. So we look at the maximum value of AI, and let's say that's for some AI. Then we know that BI, which equals AI minus 1 plus AI plus 1 over AI. Since both AI minus 1 and AI plus 1 are at most AI, this is at most 2. And we repeat the same thing when AJ is minimum, we get that BJ is at least 2. But because AI is at least AJ, maximum and minimum, this implies that BI is at least BJ. But one of them is at most 2 and one of them is at least 2. So in fact must equal 2. And so, for example, if this equals 2, then this implies 2AI equals AI minus 1 plus AI plus 1. But AI was maximal, so AI minus 1 and AI plus 1 must also equal the maximum. And then we just keep repeating this until this covers all the AI. So we get all the AI are equal to the maximum. So they're all equal.
Yeah.
Okay, great. So what are we doing next? Problem 2 or problem 4? Or...
Problem 4, probably.
Yeah.
Problem 4.
Therefore,
Oh, turbo.
Therefore,
Do you want to just finish problem 2 though? Because we do somewhat realize what it is. Or we can just do it in order.
Yeah, let's just do it in order.
Okay,
Yeah,
problem 4 then.
Yeah, not 4, let's do 2 only.
Oh, that order. I
2.
see.
Okay.
The orthocenter of a triangle is the intersection of altitudes. Yes. Just a second, I'm putting it here. Yeah. So, yes, Archit is drawing a diagram. So we have point D.
D is antipode, right?
Yeah, D is maybe a bit more to the right. Okay, relevant. Point is we have some K and L here, such that AKL, or in fact, let's just translate that tangency condition to this angle equals A, this angle equals A, and A. And we want to show that KL actually goes through the orthocenter. So the InmoMock problem is actually, in some sense, rephrasing it with phantom points, I think. Like it states that
if KL goes through orthocenter, then this works.
yeah, if this is some KL, and if this is such that ML equals MK,
Yeah.
which because HM dash are HMD are collinear implies DK equals DL also. And in this case, the equal tangents is giving DK DL. So in some sense, it's the same. Okay, how did we prove this problem? We had the 90 degree. Can we do that here? So we have angle DCA is 90, angle DBA is 90. So this is isosceles. So let's just drop the foot. This is supposed to be our orthocenter, right? Let's call it H dash. So we have H dash LCD cyclic and KH dash DB cyclic. How do we get orthocenter?
Oh wait, you get DBH prime C is parallelogram. Yes.
You do? I see. So angle DBH prime because of the cyclic equals angle DKH dash, which because of the tangency equals angle BAC, which is the correct angle. So this is actually implying that BH dash is an altitude. And similarly, angle DCH dash is also equal to angle BAC. So yeah, this is also an altitude. So H dash is actually equal to the orthocenter. Yeah. Does that work?
I have no idea what happened.
So like, let's just drop the foot from D onto KL and call it H dash.
All right.
So this is antipode. So we have DCA equals DBA is 90.
So that's cyclic. Yes.
Yes, you have this two cyclic also, DBKH dash and DCLH.
Yes. Right.
So we get angle DCH dash is A because DLH dash. Yeah. And you repeat the same thing other side.
Oh, yeah. And then you just get H's out.
That just implies H dash is actually the orthocenter. So KL passes through H dash. And this is funny because we've sort of seen this exact same problem before in some sense.
Yeah.
Okay. And that was just basically the proof. We dropped the foot from D onto KL and these cyclic quadrilaterals give us angles DBH dash and DCH dash, which are the correct angles for the orthocenter. So we're actually just done.
Yeah.
Okay. So what next?
Next, P3.
P3.
Okay.
Turbo the snake.
Or do you want to do 4 and 5 and then come for the last ones?
Yeah, I'm scared of P3.
Yeah, let's do 4.
Fine, let's just do 4 then, get done with 4 and 5, and then we can go for 3 and 6.
All right. So Turbo the snail. We are of course very happy to see Turbo return.
We read the problem.
You haven't seen it either. I'll just put it on Miro first.
Yeah, I put it on Miro. I'll read it.
Long crossing. Okay, most of it is just the diagram.
Okay. Interesting. Basically, like you have like a circle and you have a bunch of positive real numbers. So each time you either choose if you want to travel that clockwise or anti-clockwise. And we have to show that if the sequence of reals is bounded, then there is some point on the circumference which it can never touch.
Not bounded. It's asking you for the bound, right?
Oh, right. Yeah, determine the largest. Yes. I mean, obviously, C can't be greater than 1.
Yeah.
Right. Because if it's 1, then you just go and you visit everything.
In fact, C half
Can't
is
be
also
greater than
valid.
0.5.
Work out, right? You
Yeah,
just-
because you can never go to diametrically opposite. You're just like, I'll always move away from the diametrically opposite. Okay, so wait, does half work or not? So half works.
exactly half works.
Yes.
Anything
So
Surely
does
it's the
less than
bound,
half.
right? Because it's so close.
So does less than half because he just goes there and
This
then
is
he
largest
returns along the
constant.
same arc and then he never visits anything over here.
Yes. Like you just if you start here, you're just
Yeah,
like,
you
I'll
just
never-
split it into two parts and then one part it never visits.
Yeah, like if you're in the left half, you just move over to right. If you're in right half, move over to left.
Yeah, so like there will be, I guess, some length varies, like
That should work NEC less than 1, right?
Yeah, but it's the largest constancy.
It's
Wait, also, what we NEC less than 1?
Yeah, like if C is 3/4, it travels clockwise and then go anti-clockwise.
Yeah, but I don't need to put all C.
yeah, you can put things smaller than C.
Yes.
That is what I was saying. Like, what-
So is it just enough to show that?
Wait, hold on. I'm not convinced with C's half. If you have something here, you just like, okay,
opposite. Always start farther.
let's say I give you half. So then you would have to move here, right? Necessarily.
Like the point is, let's just fix some point, let's say X, right? So
Yeah.
you can always, there's a smaller arc to X and a bigger arc to X.
Yeah.
The bigger arc is at least half length.
Yes.
You can always go along the bigger arc, you won't cross X ever.
Yeah.
Okay, but
The half seems right.
sorry?
How do you show it best?
The
Yeah.
half seems right.
So basically, we just have to show that if C is, say, like if everything is less than half, strictly. Like,
No. You're allowing half.
Yeah.
You're allowing half and a few bigger things.
yeah, right. You need something greater than half. At
Then
least
you
half.
can ensure that. And also the sequence has to work for every point. It's not like Turbo will give us a point and we have to make sure Turbo will go over it. After seeing our sequence, Turbo decides.
Yeah.
Because Turbo can, after studying the sequence.
Yes.
You haven't given too much freedom to me. Like giving the same length to Turbo twice in a row is useless because Turbo will just go back and forth.
See, the main point is you're allowed to have half, which means you can instantly transport anything to its antipode, irrespective of what he decides to do.
Yes.
So like, you can just instantly switch it to the antipode, or yeah. And if you give it something, say, well,
Okay,
everything can be just treated as something at most half, right? Because
Take
Wait,
half.
what?
yeah, because if you have counterclockwise something long, then you can just replace it with 1 minus that.
Sorry?
Right? If I have something like move X clockwise, then I can just replace it with 1 minus X. And then it's again same thing, either this way or this way, because circumference is only one, right?
The real difference is that half is allowed.
No, but also like if I tell you 0.7 from here, you're forced to go either here or here. Okay, that's the same as 0.3.
Yeah, that's same as 0.3, exactly.
Yeah, so you're just allowing half.
Yeah, so it's like you only have a couple of halves in between and everything else is strictly less than half. So we can only use these halves to actually get a contradiction.
Yes.
Because
Okay, so
like in the
halves are
case
very
of half, the result is fixed. It just goes exactly to the opposite point.
Yeah.
Yeah.
So you essentially have the normal game with less than half, but you're allowed to transport to anti.
Yeah, exactly.
Yep.
Okay. How about we just play it like I'm Turbo, give me length.
I think just send to the antipode and then whatever point he's planning on.
Yeah.
No, but then no,
the point is he doesn't have to plan a
beforehand.
point.
The sequence is fixed beforehand.
Yeah. So like as you give the sequence, he just needs to ensure
Yeah.
he won't do weird.
Yeah, so let's just fix a point because sequence, like the choice of the point is irrelevant. So let's just fix a point P.
Oh, also Archit, what you said is not true. That you can assume less than half always. Because although if you start here and you're only allowed to go here and here, the difference is you're actually going all the way. All these points are also included now.
Oh, yes.
Oh, okay, yes, that makes sense.
So you are given something more than half also. So like it's not just the points you visit, you also need the path you took.
If you take something smaller than half, then something smaller than half, and then half again.
Can't we just take half and then 1/4 and then half?
Half 1/4 and half. Then the 1/4 must go this direction, and then the half must go this direction.
Yep.
So
And then
half,
this again.
1/4, fine. And then
But
half back.
half
I see.
again. Oh,
Yeah.
I missed that.
Wait.
No, also like in this itself, why can't you just do this? Like you first give it half, so it goes from here to here, and then you give it 1/4. It'll just return back.
Also show the path you're taking. That's also important.
First
Yeah.
this, and then this.
And then they're saying half again.
So it just goes here. That's the best you can do. It can ensure, I guess, that it never visits this. If you just do half or something, half and
Yeah.
1/4, right?
So you sort of want to cover some quarter thing.
Yeah.
But how do you do that? Also, actually, we can assume you can never use anything less than equal half. Okay, you can't. Fine.
No, why not?
Yeah, you're right. You can. Like I was thinking, instead use 1 minus that, but you might not be allowed 1 minus.
Yeah, but then, okay, yeah, that
the
is
half 1/4 thingy. You take 3/4, right? Now start the exact sequence from that point again.
Again, I mean, what if I just choose to avoid you?
What if I just retrace all the paths? Like everything is
Yeah.
fine. I can just retrace whatever it is. No, I don't think something as dumb as 1/2 and 1/4 should work, because
Yeah,
then
we
that-
need something more than
Yeah.
half also.
we have like, okay, so let's say we are C is equal to say half plus epsilon, and then we're allowed to use stuff between half and half plus epsilon as well. That is the
Also,
only
let's assume half plus epsilon plus. Like I want to use half plus epsilon because it said less than C. Always. Like,
what is less than 0?
I'm just saying allow half plus epsilon. I just want some number to be.
Okay, makes sense. Fine. We could just pick epsilon by 2 or something.
Yeah.
Wait, doesn't that just work? You go to the antipode, then you do the half plus epsilon. It always has to go to the back. You get an extra epsilon every time.
Why does it have to go back?
Because
What if it
otherwise
just?
it covers the entire semicircle on the other side.
I see. Wait, so what are you doing? Half and then half plus epsilon.
Then half again, then half plus epsilon.
I think that is easily avoidable. I don't think that does anything.
Oh
You
wait,
have this.
wait. You're right.
Yeah,
And you just need to
If this
do
goes to the
enough time-
antipode, and then you give half plus epsilon. So okay,
It
let's
has
say
to go left.
Yeah, let's say you went this way. Now you go half plus epsilon back. So you're going slightly more to the left, right?
yes.
And now when you do half, you can't really go this way again because you'll cover the whole circle.
So go
So
this way.
instead go half. Which way?
Yeah.
Now you
And
go
then half
this
plus
way.
epsilon.
Half plus epsilon. So you're coming back another epsilon here. And you do this enough times so that you do this 1 by epsilon times or something.
Oh yeah, and
Yeah.
then slowly
And
this
you will
entire
just-
thing fills up.
Yeah, you'll eventually fill up. Interesting.
Oh, interesting.
Okay, that's nice. So like the point is, you can just never keep going.
Alternate. See,
You need to
the
keep-
main thing is that half is very helpful because it just says there's only one possible place it can end up at.
Yeah, if you're taking
Yeah.
anything at least
So-
half, you can never go twice in a row in the same
Yeah.
way. That's a good.
The thing is basically if you're applying half and like there's some arc which you have covered already, and this arc length you can increase every time by at least epsilon, and then eventually
Yes,
in one
every
epsilon
2 moves.
turns it becomes 1.
Yeah.
I think you can in fact say something like 1 plus 1/2 epsilon, right? Because in the first thing itself half gets filled.
Yeah. Also
Probably.
2 by epsilon.
No, 1/2 epsilon, right? Because there's
So
only
every
1/2.
2 moves, you're going by 1 epsilon.
Oh yes. Okay. So it's just 1 by 1 plus.
One-
It's one.
yeah.
Yeah, it's that only.
And they didn't ask for bound. This is not 1.
Okay, interesting. That was.
This is actually nice.
Yeah.
That's actually quite clever. I just wanted to use small stuff. Okay, but this makes sense. It also shows why.
Yeah, so you could have also shifted between say half and oh yeah, that no, never mind. That
Just half and anything bigger than half.
yeah,
Because
anything bigger than that.
You're not
But-
just tending to small stuff.
Yeah.
Okay, so we are done with what? 1, 2, 4.
Now let's go for 5.
Okay, I'll also just
Yeah, 5
check.
looks interesting.
Yes, that's twist thing. I'll also just check the live chat in case there's anything people just said.
Okay.
Yeah, I'll also just put the
Right.
5
K is
thing.
AS plus B, and then you define something called
That
twist.
versus, oh, hello, Aryan. I did not.
BS.
Sorry, this is standing.
Okay, and now what? Now you have. Okay, you define this infinite sequence, and di plus 1 is the twist of di for each positive integer.
Like also, what is the point of twist? As in, aren't you just every 2 moves going back to original?
No, you're not, because if
No,
like
A
S
can
is
be
pretty
anything,
large,
right?
then like A can be large, right? Exactly. Like if A is, say, let's say I take S cube or something. Not S cube. S cube is a bad example. Let's
S
say I
square.
take something like S
Okay,
square
fair enough.
S.
S
Then after one move,
Also, what is the problem asking mod S square minus 1? What is mod S square
Yeah.
minus?
show the paper once. Have you pasted the problem yet?
Oh, just a second. Where does S square minus 1 come?
It's 1 S mod S square minus 1, right?
Sorry?
What was problem?
Sorry, which problem?
And this problem, what you had to prove?
If it eventually contains 1, then must have begun with 1 or S, mod S square minus 1.
Oh, it contains if and only if n is divisible when n is divided by S square minus 1. Remainder. Oh, what? That is
The
random.
remainders are the 1 or S. It's interesting.
From
Okay,
AS
first let's start with the easier case, which is probably when n is congruent to 1 modulo n S square minus 1. Like what happens to these numbers modulo S square minus 1, say? If you subtract,
Square.
You're going from 1
Square is
to
invariant. Oh,
B is just like, you can treat that as what?
take
B
square
by
of
S.
number is invariant mod twist.
You just
square.
divide by S every single time, right?
What square? Divide?
And AS, take a number.
Like modulo S square
Square.
minus 1, you're just dividing. And so eventually it should loop, I guess, right?
Oh, 1 by S is S.
Yeah, exactly. 1 by S is S.
I see.
Modulo this.
Like, pick a number, its square is congruent to its twist square mod S square minus 1.
Always?
Yes, that's just the square.
AS square.
Yes,
Okay.
there is A plus B.
So square is always the same.
So n square is 1 mod S square minus 1.
Oh,
N
Yeah.
can be minus
that's
1.
interesting.
What?
I mean, aren't there other possible roots like n plus 1? Wait.
And minus 1 also works, right? Minus 1 square.
Yes.
I mean, square remaining constant is fine, but isn't this stronger? Because
Yeah, this is stronger,
really,
what I should say.
not really, but because like after 2 moves, anyways, it just starts repeating.
Yes. Okay.
Right. So if we can somehow show that it's decreasing all the time, then it obviously is hitting 1 enough times when you consider S and 1, because the
Wait, also
cycles
not even
S to 1,
decreasing, nah? Like
1 to
you're going
S.
from n to n by S square, and so on.
No, but
Like
that's modulo S square minus 1, right?
Huh.
And B is too small here. Like B is at most S, so this eventually decreases.
This will eventually decrease, yeah.
Yeah, and then because stuff is remaining constant, like modulo S square or whatever, after every 2 turns, it eventually becomes 1. Because
Yeah,
see,
so,
you're
okay.
starting with 1 or S, so S will go to 1, 1 will go to S, and then it just keeps looping, and
That's
it
the
keeps
only thing. Yeah.
like a spiral or something. It eventually meets at 1,
Yes.
and you drop down to 1. The other
Yeah.
thing is, how do you prove that if it eventually contains 1? And I think that's easy by backtracking, probably. Like
No, not even
inductively
just
backtrack.
eventually contains 1. Like it eventually contains the residue 1, but it's smaller than S square minus 1 eventually.
Oh
So
yeah,
it'll
no.
be-
Even easier. Like if it
Huh.
contains 1, it's congruent to 1 modulo eventually, and modulo S square minus 1, you're only divided by 1 or S.
Okay, fine.
Right, so done already, because yeah.
Okay,
So
for the sake
this-
of people watching, we'll again do this.
This is
So-
Hmm? Probably not P5 level. I'm not sure. Is it?
Okay, so the observation that Arshit had is that if you just divide AS plus B by S, then this equals A plus B by S, which mod S square minus 1 is just congruent to A plus BS, because S square is 1, so 1 by S is equal to S. So in some sense, the twist of a number, which was denoted by di plus 1, right? So di plus 1 is just congruent to di over S mod S square minus 1. And it is fine to
There are
divide
some
by...
annoying edge cases, by the way. Like when does this strictly decrease or not? I guess at S square minus 1, we have some trouble probably. When
the
A
point is eventually it's 1.
exactly is concerned. Yeah, but then it doesn't matter because that just doesn't.
And also dividing by S here is fine because S is co-prime with S square minus 1.
Yeah, that's this small detail.
Yeah, and dividing di by S square is nothing because S square is just congruent to 1. So the
Yeah.
only possible residues that this sequence takes is either n or n by s.
Huh.
Mod s square minus 1.
It
So
in fact
eventually
swaps
this
between these.
residue, if this we're doing one direction, then assuming eventually it's 1, then if it eventually is 1, then one of these must be congruent to 1. So n is either 1 or s mod.
Modulo s square minus 1.
Yeah. And the other direction is if n begins congruent to 1 or s mod s square minus 1, then we just want to show that it will eventually reach 1 itself. But
Yeah, that
yes,
so there
that's
is some detail in that, I guess, exactly, because if you have as plus b and if you have
Smallest
bs plus a, so if the twist does not decrease, then that means bs plus a is at least as large as as plus b, say, and then you get what b minus a times s minus 1 is at least this, whatever.
That will be only
And
to an A.
then you get b is at least a, which means a is at most s, and then now you can just bash it because modulo s square minus 1 that fixes the value of a to something, I guess,
a is less than equal s.
because b is a remainder, right? So s is greater than b.
Yeah.
So if it does not decrease, if it's at least as large even after that,
Yes.
then you must have s greater than b at least a, which means a is
Then
itself
it
is,
cycles, right?
which
I mean,
means
a is less than s. They
Yeah,
gave
A
it
is
up.
less
S, then it cycles. Then AS plus B goes to BS plus A, and then it cycles back to AS plus B.
Yes.
So
If
they-
both a and b are less than s, then it eventually just starts cycling as plus b, bs plus a.
yeah, but that's not possible because if modulo s square minus 1 you are 1 or s, then
Yes.
that won't happen. It won't work out, right?
Yes.
Yeah.
And why does it eventually go below s square minus 1?
It's always decreasing.
Because it's always decreasing, right? Because if it
always
doesn't
decreasing.
decrease at some point, you have size issues. See, if a is at most s, then what you get? If a is strictly less than s, then
Then
this
you
is at
cycle.
most s minus 1 times s plus s minus 1, which is s squared, right?
Why is this? I mean, this is not necessary, right?
Or not this, s square minus 1. No, this is b is what? B is
B can be big.
B can B
No.
has to be less than S. B has
b
to
is
be
at most s minus 1.
Yes,
B is the
B is
remainder.
Yeah.
Yes.
And A is also at most this, because when you refer it, it didn't decrease, which means that
Oh,
B
B.
minus is at least 0
Okay.
when
Fine.
you subtract.
Fine.
So you get this, which is equal to exactly s square minus 1, which is impossible because it's congruent to 1 or s mod.
Yeah. Thank you. Okay, that works. And while you people decide what to do next, 3 or 6, I'll just see if the chat had any questions.
How many people are watching?
I'm not sure. I'll check. We have 8 currently. Yes, also hello, Ari. Okay, so 3 or 6 first. Can we do 6 because it looks like config stuff with mixed linear attachment? We can leave the combo for the end. Like everyone knows combo P3s are impossible.
Are they though? EGMO
Yes.
2017 P3 is not impossible if you think about it carefully.
Yes, like not all of us can think about it as carefully as
You're the one who told me the problem.
I'd seen the solution before I hadn't solved it, but also long ago.
Okay, let me draw the diagram.
Yes, let's draw that. Oh no, this is not my kind of view. Random tangent circles.
Okay. You have a triangle ABC.
Circle.
Euro circumcircle. It's fine.
It's fine. I know how to draw perfect circumcircles.
Well, we'll see.
I mean, that's almost perfect.
Oh,
You
that's
can't-
Good.
actually.
And I'll just draw SB and wait, SB
Yeah,
is midpoint of which
NA
arc?
is midpoint of arc BSC, so it's like here.
This is SC. This is S. Also, NA is just irrelevant. As in, it's just for mixed linear attachment.
Okay, let's just still keep it. You never know when it might
Yeah.
come.
Okay, let's say I is here. Clearly, BI,
Okay, never mind. Yes, and you have
BISP and CISC. are
yeah,
here.
draw those two. And
What is the problem saying?
omega b with a circle that is tangent to AB and internally tangent to omega at SB.
Siddharth and Kanav, you have to solve this because there's no way I'm doing this.
This is also some touch thing, right? I'm pretty sure inversion should help.
Tangent
Okay. If it's inversion, Arshit, you can do it. We have something like this, and the other circle looks like this, something.
Yeah, that is not good looking at all. But let me draw the circle for you.
Leave it. We'll see.
Remove those two. I'll draw a better circle.
Let's just see what we can do.
You just
Also,
want INA has equal power with respect to omega B and omega C.
IND.
INE, like the intersection of INA with omega has equal power with omega B and omega C.
Yes. Yeah.
Okay.
We just want T to lie on the radical axis where T is mixed T touch point.
What do we want to show anyways? We want to show INA and the lines of intersection of this meet. So you have to show that INA intersection what again?
ABC.
Omega rise on the radical axis, right? So, and
Yes.
this is just the touch point. No, so introduce that circle as well.
No.
I mean, okay, that's badly drawn, but let me try again.
What? Oh,
Yeah.
I see. You're right. That collinearity is actually very true.
What
The
collinearity?
is nice.
These tangency points are actually just on
Yeah, they're all one line.
SBSC intersection.
Why is that? Homotheity?
These are midpoint of arc. So yeah, homotheity. This yellow circle to green circle.
Okay, yeah, makes sense.
What do you want to call these? E and F or something?
Do we see any good lines? Whatever. We need to like pick a good line, 2 good lines through T, which will help us compute the power.
2 good lines?
INA is a good line.
Yeah,
A?
through T.
Power from I shouldn't be bad.
Because you want to show that power of T with respect to omega B and omega C is equal, right?
It's weird.
Yes.
So you just have to like take 2 lines and just show that, okay, this product is equal. Some similarity.
Yes, but that's sort of weird.
Yeah, it's probably not like that.
Like the yellow circles, I don't like. Very rude there.
We should invert to get rid of them.
Invert where?
Good.
Yeah.
Okay, I mean last year, wait, EGMO has needed 2 inversions so far. 1.
I mean, technically, you can phrase any problem without ever referring to
I mean, sure.
any solution, because you can just be like, okay, magically construct this point.
EGMO, I mean, inversion is significantly helpful in reducing problem statement to something nice.
Yeah, okay, that makes sense.
Wait, A is on the radical axis, no? Okay, this is a terrible diagram then.
I mean,
Like,
you
Is
guys
A
know
on
the
the radical
circle.
axis?
A square is AF square because this line is like perpendicular bisector of AI, no?
Oh,
Like SA is SI, I mean SCA is SI, blah blah blah. So, so actually A is on. Okay, okay,
That's
Arshit, you can do your
EA
nicer
is
circle.
EI. EA is EI, right?
Sorry,
EA is EI.
EA is
EI.
Yeah.
EI, yes.
And EI is EF, is that?
So wait, that's a rhombus?
No. It's a rhombus, yes.
How is AE?
AEIF is a rhombus, right?
Sure.
No, how is AE?
AE is AF.
Yes, how?
Because this SC is perpendicular bisector of AI.
Yes.
So EF is perpendicular bisector of AI. So this is
Wait, why is
perpendicular
this-
angle bisector.
Why is this the perpendicular?
Ah,
Because SCA is SCI, SPA is SPI.
Oh, yeah.
By-
Okay. My bad. Yeah, makes sense.
whatever.
Makes sense. That's classic stuff.
So we want to prove that AT is the radical axis.
Yeah, 80.
Now invert about A, I guess. Root BC.
Every 2 minutes, Arshit will suggest inversion. Okay, why not? What does root be seen? What do those yellow circles go to? That's
I mean, the circle becomes a like just line BC, so that will clear up that. It won't be that bad. Those circles at least.
but
okay, fine.
I think inverting it one of the SC or SP makes more sense.
But how will you evaluate other points when you invert about that?
Yeah.
then do it.
It's not necessarily true that if there's more circles going to a point, inverting about it helps. Like it's a general rubric, that is true, but it doesn't mean that you can often do it. If there's a lot of overlays in a diagram, then you can get away with it. Like here, if you invert about A, there's a lot of overlays.
Where does T go to? Okay, T doesn't matter. We can just look at
T
that
goes to
line.
T is easy to T just
No,
goes to
we don't need it. Like we just want line 80 to be
T
radical.
goes to the X circle touch point.
Yeah, X tangent.
Okay.
But the circle
What do yellow circles go to?
is still bad.
Yellow circle, it basically touches what? AC, so it means it will touch AB now.
ABC again.
And
ABC again, right? Achha, right. I'm sure.
ABC just becomes BC,
Yeah,
so
yeah,
it just
yeah. understood.
Yeah.
So
And
tangent to AB and BC
it
and
passes, like, how are these circles defined again? Hold on, let me see that.
passing through S. Where is SB going?
It's tangent to AB and it's internally
SB
tangent
is weird. I don't like this.
SB. No, SB is not weird.
SB is going to weird point.
Is it?
I mean, okay, what is the sample?
No, you have good angles. You have SB what? You
Like-
have SBAC equal to SB.
Okay, you're drawing the line parallel to BI through A and intersecting it with BC. Something.
No, it's SBAC is equal to ACSB. ACSB, which means that in the
This
inverted
is
diagram,
SB dash.
we get SB is becoming SB star, A, and
SB
then
dash, not star. Star is too fancy.
I always use star though.
Okay, star it is. SB star. SB star is just this point, which is
What point?
But the line, you take the line parallel to BI through A and intersect with BC.
That's not so bad. Is
That's
it?
weird. I mean, the circle is now the circle
To SB.
passing through tangent to BC and AC passing through SB star.
Yeah, so that's the in circle of something,
It is.
right?
I mean,
It's
Yeah.
gonna be.
No, it's not. It's not. My bad.
It's
It's
just
weird. I mean, it's not weird. It's this. It's this, right? Some circle like that.
no, I mean, it's tangent to
AB.
AC now, not AB.
AB,
It's not
AB.
X circle.
Oh, you're drawing the image of this circle. Okay, that makes sense.
Huh.
So that's like it touches here and it also touches this, which means it's like what if you draw this or something, extend it a little so that you can draw a diagram properly.
It looks something like this.
So you have homotheties from the in circle to this, so that's not so bad.
Okay, we have circles and we want to show the X circle touch point is on. Oh, that's not bad. No, you just want to show midpoint of SB star and SC star is the X circle touch point.
Yeah, exactly.
Oh, that's actually very nice. Okay.
Yeah,
Archit,
that's easy to prove. I've seen this before, I'm sure, like this exact
this before.
same points SB and SC.
Okay, wait. So we can actually delete so much.
Yeah, exactly.
Delete,
That's why you
delete,
invert.
delete,
There's a
delete.
reason-
Okay, fine. Archit, I believe you now. Inversion is great stuff. Delete, delete. Okay, I'm just saying delete a lot because it's fun. Wow.
You
I
should
should
even bury it.
No, no,
You
no.
can bury it.
No.
You can bury it.
Don't
I-
bury.
Archit.
Don't
No.
But you can like this.
Yes,
BI is
I'm
like
sure you
it's a
can,
nice
like-
line, and then you can draw stuff parallel to A through that. That's easy.
I'm sure you can. Like, you can probably pull off barrier on anything, but that is not what we will do here. This is just lengths. Length bash? Okay.
And bash.
No, Kana, please. Let's be nice. Yeah. So we're just drawing the line parallel to.
Okay, hold
Yeah.
on. That last line was very bad.
Okay, that's also not parallel. Why can't I draw? Okay, there we go. Huh. So this is SB SC star, and we have an X circle touch point E. It's called E.
Yes.
Prove that E is midpoint of
So
S.
that's same as showing that SB star and SC star have same power with respect to X circle.
That's true, but
But
how is that? How is that used?
That's a good question.
Okay, also like if we don't find direct synthetic, like AI intersection D length, very cool.
Yes. You can
And
easily-
like CE is what? S minus B here.
you can easily
Okay, no. There's probably something even simpler you can do here. Look, first you have what is you want to show SB star or D is equal to SC. No, not D. My bad.
let E.
SB star E is equal to SC star. No, that feels wrong. What did I do? Oh yeah, SC is supposed to be here. No wonder. Yes, SC star E. You want to show this now?
Oh,
That's equivalent
you're
to
done.
trying
You're
to show
done.
that.
AB
What
is
happened?
SB star. This is AB. SB star B is AB because this is B by 2.
Oh,
Oh,
So
bro.
you're done.
Bro.
So you're done.
Oh, and then obviously no. I'm
okay,
just
this
going
is
to-
C.
Yeah,
So this is
that's-
S minus C here. This is B.
Wait,
Yes.
wait.
Huh.
BE
C is opposite to AB
Okay,
is
wait.
equal.
No.
Another.
Fine. Yeah, you're done.
Oh, you in fact have like this wherever it hits this. Like these two are. This is probably like congruent triangles, right? Or this thing and this thing.
Huh.
Right.
Indeed. Yes.
Interesting.
But yes, we are done. Okay. Kind of very nice observation. It saved us some trouble.
That was
Yes.
just simple, right? You had to apply sine law and AB SB star. Then you notice you have nice angles.
Oh, also you don't need sine law. I was thinking just parallel lines. So we just But yes,
But
what you
still
did
yours
is
best.
Okay,
Huh.
this is why you invert.
Yes.
Okay, Arshit, we believe in your inversion now.
Inversion isn't that bad.
Okay, let's do P3 now.
We have just one problem left.
Hmm?
We just one problem
Oh,
left.
one problem left. Wait, how much time is left?
45 minutes. We've done 5.
Huh. Okay,
I mean, there are 4 of us, so it's helpful.
that's true.
Sure.
Let K be a. Okay, just paste it here. I'll read it on the
Yes,
window.
yes. Snipping tool, time taking. There.
Okay,
Oh, I'm at 75.
fine. Let K be a positive integer. Lex is a dictionary. D.
Lexi has a dictionary.
Why is it a dictionary? Wait,
Lexicographic.
Also-
Dictionary is a set of words.
I mean, call this a binary string, no? Like,
Yes, that would be better.
what is A and B? Fine.
Containing only letter lexical to write either the letter A or the letter B. Each code is true.
So you're given a bunch of binary strings and you want to fill a grid such that every row and column read in the correct way is a
Yeah, and the
string.
point is, if D is too small, then when you try to get everything in D to get included, some other excess stuff will also get
Yeah.
included.
A small one. It's just that I for K equal to 2.
Yeah, let's try K equal. K equals 1.
Equals 1 is 2.
Wait, so like if
Equals
ze-
1
like,
is 1,
as
huh?
the dumb example, if 0000 is in D, then it just works, right? Because you can just have everything.
Yeah, all
Fine.
strings
Add
is
everything.
stupid.
That's fine.
Wait, how is it 1?
Like for K equal,
Like,
you
if
just
the
give me
dictionary
one
is just.
string, I'll just put that string here. No?
If D
For
is
K equals 1.
1,
Okay.
0, 1.
So, okay, K equals,
No matter what strings are in D.
there is 1.
K
So, okay, for K equals 2, I'm not giving you 0, 0 or 1, 1.
has to give 0, 1.
0, 1, and that's
Then
not
you're
enough.
dead, right? Wait. If you're 0, 1, then you must have something that starts from 1.
Let's say I give you 1, 0, then you can do this.
Then you can
right?
do it because just alter this.
Okay, so K equals 2, you can do
I
2.
think for the construction, we can use something like size, right? Just include all the binary numbers which are at most some number. And then when you sum up individual bit positions, everything is too small. But then that's
Right.
not possible because you do have a lot of bits.
Yeah. What if I just focus on one row? And like your first row is not going to
This
work.
idea you can do stuff. Right?
Wait, and for K equals 2, it's like M equals 3? Or even, is it larger than that?
M equals 2, no? You
What
only have
about 0, 0, 1, 1?
0, 0 you give, I can just fill with all zeros.
Yes.
Makes sense.
And all ones also.
Yeah.
Should we do 3 cross?
Wait, what
Oh,
if I just tell
3
You
cross?
can.
what if I just tell you like no 0 starting? I just give you like 2 to the power
Then 1, 1, 1, 1 must exist.
K minus 1. Okay, no 1, 1, 1, 1, 1 also.
Yeah, so that just gets you like 2 to the power K minus 1 minus 1.
Yeah, but this you can't do anything.
Yes.
Yeah, this
Because you don't have
this
anything
can't-
starting with
maybe
this.
the answer is 2 to the power K minus 1.
Yes.
That would make sense. It's consistent with everything we've obtained so far.
It is.
Yeah.
1, 2. Okay, I was thinking linear, but okay, that's stupid. Too many strings. Okay, so given 2 to the K minus 1, you want to do.
Okay, so you have 2 to the power K minus 1 strings. You want to show that it's not possible.
It is possible to
Oh,
array.
it is. Yeah, it is possible.
What's the point of 2 to the K? Okay, it's telling you that at
Maybe-
any bit, you can have any number you want.
No, so you can try to induct over here. Like, see, first you look at the number of strings that start with 0 and look at this number of things that start with 1. One of these will be larger. So that's at least 2 to the power K minus 2, say W log 1.
Okay.
And now you induct because you can do the ones and then you try to place these zeros carefully. Something like that.
What? I mean, you're not just doing the rows, right? You want to do the columns also. How are we arranging the columns if you're only looking at these rows? Also, induction seems pretty bad because it's too restrictive also. Like, suppose I just fix some string like this and I don't know, 0, 0, 1. Then like in this remaining board, you not only want a valid thing, but also like stuff satisfying this. it needs to start with these things,
Yeah.
which feels like a bit too much to hope for. And obviously we can permute rows and columns to start off with. That doesn't. Those are one first.
What like we should probably try to characterize all stable sets of strings where you can do it, and then try to show that every set of size at least with per dimension is stable.
Like that feels a bit like you just have so much freedom in your
just
string
look at,
choosing.
say minimal stable sets, because obviously if you introduce anything to a stable set, it remains stable.
Sure, but
And if you can show
even
that
then-
all. No, it's like you have a bunch of strings which you can currently do it, but the minute I remove one, it all goes away, which means that every string must be appearing somewhere in your whatever writing you made.
sure. So minimal stuff has size at most to 1. But like, how are we even constructing this kind of stuff? It just feels so weird. Like doing it for even one column caused a contradiction for 2 to the k minus 1 minus 1. Like all rows in one column was bad.
Maybe the answer is not 2 to the power k minus 1.
Yeah, maybe not. Matched our first few answers.
What if we try something a bit more weird, like no 0, 1 starting, no 1, something like that? Probably is not as useful. No, I think I feel like this should be the answer. Like
It's a
2 to the
nice
power k-
answer. Like I would like it if that was the answer, but it's just so weird that all rows in one column is enough to imply you can do for all rows and all columns.
No, that would actually make sense, because it maybe in an optimal answer, like half the bits of the strings match, because
Yeah, makes sense.
because when you're saying different strings, you should try to make use of the fact that different only means even if one place is not the same, it's completely different,
Sure.
right?
And also the advantage of 2 to the k minus 1 strings is that we know at any place you have some string with 0, you have some string with 1.
Yeah.
Yeah, from that we can just ensure rows.
That what?
You can ensure like rows are consistent,
Yes.
but columns.
If you fix one column and all rows. But where are we getting all these columns from?
like you still have a lot of freedom if you're just doing rows, right?
Yeah. Like I just don't get this is
Do we have
how are we even controlling anything?
yes, do we have a bigger construction?
Yeah, you want to try k equals 3. I'll give you 4 random strings and you can try.
Sure.
Okay, so for k equals 3, I'm giving 1 0 1, 1 1 0, 0 1 0, 1 0 0.
Oh, wait, no, never mind. That's just ugly.
It's a 3 times 3.
Oh,
It's
my bad. Fine. Just start with say
1 1 0.
no, and then you here hit up 101. And now
1
you
1 0 and 1 0.
1 0 here.
0
Oh, but
1
there's no
0
0,
0 gone. Okay, so we can't do 1 1 0 and 1 0 1.
This has to be 0 1 0.
Yeah.
And then you can have put a 0 here, and you can again put a 0 here. That works.
Yes.
0
No,
0 1 is
0,
not
1
allowed.
doesn't-
0 0 1.
Yeah, 0 0 1 doesn't exist.
I think 1 1 0 at the start makes no sense. 1 0. And then 0 1 0 at the middle. Yeah.
0 1 0, and then you put a 0. Yeah, that works.
Huh. Yeah. That felt lucky. I don't get any intuition of how this works.
But this is
We just got lucky. Huh. Are there any other constructions beyond? Okay, probably not. Okay, I'll do k equals, let's do k equals 4. Except I have to give you 8 strings. 1 0 0 1, 1 1 0 0, 1 0 0
I
0,
mean, it'll become
0
just
1 0 1. Yeah, like maybe if we can force ourselves to do something beyond trial and error, just give in a bunch of strings. 0 0 1 1. What else? 1 1 1 0.
Maybe it's something of cyclic. Maybe we can prove that has to be a cycle if there's at least 2 to the k minus 1.
Which cycle?
Like we we join two binary strings if the last k minus 1 is the same as the first k minus 1 of the next one.
Huh.
And
That's not matching
that
the
seems
row
ambitious.
columns. These binary
No.
strings match only one place.
No, as in maybe our construction is purely symmetric. Like we just keep cycling, keep going down
Oh, symmetric in what sense? Row
across the
wise?
main diagonal.
What's the main diagonal?
The first column will
Across
be the
the-
first row.
I see. So you're just like,
Seems ambitious.
let's fix this to be 1 0 0 1 0 0 1, and we just have some strings. We want them to.
No, but then when n is even, that would mean that you need to have palindromes, which is not necessary.
No, across the diagonal. That's fine. Not across the row or column.
Yeah.
It's fine. But
We need something starting with 0 0 1. Like that.
not starting with 0 0 1. Just starting with 0 for now. What starts with 0 0 0 1 1 or 0 1 1?
You can continue this, right? 0 0.
0 0 1 1 0 0 0 0
Okay.
1. Then 0 1 0 1 0 1 1 1 1 0. That worked, but why?
Interesting. No, what I was thinking was if you can draw this graph where if the last three are the same as the first three of the next one, we draw a line between them. And then if we have a cycle in this, we'd be done. Or like something similar to this. Yeah, if we had a cycle in that, we'd be done.
You make sense.
That would make sense with like something like 2 to the k minus 1 maybe.
Because you do have like half the binary string. It is a lot. And like we probably just can't have some sort of greedy algorithm to fill in this stuff. We need some reference.
And this is the kind of thing that you can't get, like finding a cycle.
Or what if we just keep filling stuff, and the minute we run into trouble, maybe we can just change the last step and then we're done.
Yeah, but you can just run into trouble very often.
That is true.
There are so many strings. Yeah, I like the graph idea. So wait, how are we doing the graphs?
The last three are
I
the same
think
as the
one
first
thing you
three.
should remember is that in your final thing, you're only going to use like 2k of those strings anyways.
Yes.
Right.
So there's some
minimum. Like so many of them are not even going to be used.
That's true.
You just have to show that for every minimal stable set of this size, any set of 2 to the power k minus 1 strings covers at least one of these.
Yeah, that's
true. Wait, what are the strings you consider? There's only 6 strings.
I was just giving more strings and you people found something with
two more restrictions. No, introduce precisely the ones that are appearing here. Introduce anything.
Yeah, Archer just wants to like, because although you have 2 to the k minus 1, there's only some small subset that's nice enough.
Yeah.
For example, all zeros was already nice enough, all ones was already nice enough.
Yeah, exactly. So we should look for these, like minimal sets, basically.
Like, it's just nice that all zeros is working out. Like, what if we have something close to all zeros? Like, let's say 1 1 1 0 0 0. Can we? What can we do that?
By the way, we can permute strings themselves, right? Like we can change.
Sure, but overall everything.
Permuting the indices. So you can ensure a long run of zeros in the start, I guess.
How long?
How can you?
Oh, only one though. Only one though. Not
Can you permute?
It's unfortunate.
1 0 0 0. And like, I was just hoping this is nice because it's essentially for the inductive thing. It's like, I'm allowing you to start with 0 previously.
I think in general, if you have all strings,
okay, I think I have an idea.
Equal number of A's.
No. Basically, what we should try to do is you have a bunch of strings, right? Set of S of strings. You fix a certain position I, and you assign I the first column and first row, and you do it in such a way so that when you delete the ith character from each string, the rest of them can be filled up in this small subboard while not contradicting any of this. And if we can somehow ensure all of these to be say 0 or something, then it might be helpful as well.
That's true.
But that's too much, right? Because then you need 1 0 0 0 or 0 0 0 to be a part of it, which is already too much information.
Okay, I like the symmetric idea. Like, what if you just like 0 1 0 0 1 1 0? like what condition would we want on the board if you were picking a symmetric thing?
Let's say I try to avoid all the palindromes. How many palindromes are there?
I think it's definitely important that we choose the first.
Wait,
row
how many
first, not
palindromes are there?
Yeah, the first row and column needs to be chosen. How many palindromes?
The n by 2.
I mean, 2 to the floor n by 2.
Wait, that would be- right. Yeah, so I could just like take something which avoids all of these palindromes, and then your symmetric argument doesn't work anymore.
What
Right?
argument?
The symmetry
Symmetric
argument.
Where do
across
the palindromes
diagonal.
come from?
Oh, symmetric across diagonal. Okay.
So these are fine because they'll be forced to be true by the symmetric. So in fact, you're saying you don't even need 2 k strings, you're fine with k strings. Because once you fill the rows, the strings you're using for columns will be same.
Yeah, the graph. I'm not sure on what the graph should be, though. Like, what would make it connect to the next one?
Maybe like create a graph over the 2 to the power k strings, and you
Yeah.
connect 2 of these if and
If-
only if, say, the ending character matches the starting character, something like that. And now you want to pick like k vertices among these so that you have a bunch of connections. But that just seems too weak. It's not going to be.
Also, the graph is already quite
Yeah.
nice.
We need
Like it
something
is just
starting
a
with this.
three-dimensional. What if I don't want to use other things? I'm just like, wherever ones are there, I want to use this one.
You just start with the row, so start
0,
with the
0,
column,
1, 1, 0.
and then just inductively put in the next column so that the row is satisfied.
Yeah, that's the
Wait.
point. Like you are asking for too much freedom there. Like
Okay. No, listen to this. You have a set of strings, right? And each string has k positions. So for each position, you can assign 2 variables. One is like 0i and one is 1i. 0i is like the number of strings which have 0 at that position. 1i is the number of strings which have 1 at that position. Right? And then among all of these, among all the 0i, 1i, as I varies as well, you pick the largest one. For some I, if you switch all the strings around, you can assume it's 1i, let's say. So like 1 in that string s appears at least 2 to the power k minus 2 times, and this is most frequent.
yeah.
Or you could instead consider the one that appears the least number of times, anything similar to that. And now you just consider the other people, like just delete this completely and you solve it over a k minus 1 board.
It was a k minus 1
You'll
board.
be able to because you have at least 2 to the power k minus 2 strings left. So you can solve it over a k minus 1 board. And now you try to add in this character. And because there's like few occurrences of this, they should be able to fit within the others.
Yeah. So like if we wanted to pick our mystery string looks like 0 something something 0 0 something. If we want this to work out, these two must be equal. The last one, oh, all three are equal. Not all. Does this work?
Does what work?
I'm looking if this works. This works, no?
You have a string and its inverse.
Oh yeah.
Oh wait.
Oh wait. You all can always go to unit 2 to
Oh
the
my
k
God, we're
minus
done.
1 plus 1. You are?
Yeah,
Like
because
unit 2 to the k
we'll
minus
have
1
two
plus
things that are inverses, and once you have two things that are because 0 0 and 1 1 can't be there. Once you have two inverses, we're done.
Yes, you do have two inverses. Wait,
Yeah.
does this always work for inverses, or is it?
Yeah, because I think so. Yeah, it's just this construction for inverses.
Yes.
Wait, what is this construction? Like, why is this working?
You take the first string at the top, any string on like the two inverses, you draw the first one on the bottom and like on the left.
And like
on the top.
wherever you have,
you just invert it, and wherever it's
Yeah.
one, just this thing.
yeah.
That
Yeah.
would work.
So you're
But
saying
why
that
symmetric?
if we have two inverses, then it works.
Yes.
Yeah, and we
But
know
we
we
do
have
have
two
two
inverses.
inverse. Like if you pick only one from each inverse, you can't pick all zeros and all ones. So among the remaining ones, you have to have two in the same category.
Oh, and then we're done because if you have a 0 0 0, then we're already done. If you have 1 1
Yeah.
1, we're already done. Oh, so
That's
this
actually
just
very.
This is very nice.
No, wait,
Yeah.
but I'm still not clear why inverses
Yeah.
work.
I don't know why this works.
You take an
It's
inverse
just because you
and you
put it
take
on
the
the top
exact
and on the
same
left.
row.
Yeah.
Yes. And then wherever you find the go row wise, wherever you find a 0, invert the string and put it in the row. Wherever you find a 1, just stay the string.
I see. Okay.
Okay, so
There's
you're
a
saying
lot of
if I
this.
have some string S1 and I have some string S2, okay, and S1 and S2 are inverses. So I just write S1 this way and I write S1 this way as well. Now I have a bunch of characters left.
Yes.
Now I only consider S2 and I just just only work with S2, but then
No,
and
no.
because-
Also, like we're allowing you to write S1 wherever it starts with the correct.
Yes. If S1 starts with 1, then wherever in the first column at ith position.
If, for example,
one,
this is
ith
S1
goes
here,
to
1 0 0 1 1 0. So we just wrote it here and here. And now wherever it starts with 1, write this one.
write S1 again.
And where it starts with 0, write its inverse. Also not inverse. Complement.
Hmm.
Inverse. Yes.
Yeah, the 000 thing is actually very.
That's very lucky because you would expect 2 to the k minus 1 plus 1 or something.
No, because 000 themselves are useless and 111 themselves are useless.
Yeah, but like from a mathematical perspective, it's just lucky that this worked out. Like this argument does not take into account that
It's probably some random group theory solution.
group theories. It's actually so nice. Just
Yeah, this is
if
really
stable sets were just complements. Just 2 strings that are complements were good.
Yeah, and then
We didn't characterize all of them, but like if you just have complements, fair enough.
yeah, and then we do have complements because there's too many strings.
Yes.
I'm still not convinced why this works. I will probably have to.
Okay, let's just prove that rigorously that this
Yeah,
works.
prove it rigorously.
So we have some certain thing. Let's say
Do it
in this long
inductively. Do it inductively. No, do it inductively. Nah.
No, no.
No, it's not necessary.
Nothing.
And now
It's just-
we're looking at some possibly different 0 and some possibly different 1. And you just want to show that all of these 4 work out correctly, right? So because it's going from 0 here, and this is the inverse of, let's call this string 1. This is string 1 dash because it starts with a 0.
Yeah.
So as you go here, this is going to become 1. And this is going to become 0 because it's inverse. But imagine you're going down. This is also the
Oh,
inverse.
interesting. And then this is also okay. Yeah, makes sense. Yeah, this works.
Yeah. So this is also inverse. And same thing for down.
Impressive.
That's just so lucky.
Yeah, this is really cool.
Lucky.
I like this problem and I don't like this problem. Like it's just
Honestly,
mean,
like
I would probably
going to-
never have seen this, like the complement idea.
no, the complement. The harder part is knowing that the symmetric should work. That only
Yeah.
symmetric. It's like
yeah,
such a
how did you
small
even
function.
realize like let's just make it symmetric?
I didn't think it would work after also.
Just
I thought we'd have to do something more.
Yeah.
wow.
So interesting. We're done with everything now.
Yeah.
Oh yes.
And it-
We can
How long
1
did this
hour.
take us?
It took us
1
1 hour.
Full hard carry.
like honestly Arshad's carry inversion.
No,
The inversion would have taken us longer.
it was
The inversion was quite clever.
Yeah.
I would not have seen it. I would have done some weird stuff.
You guys are just not used to inversion. I would have bricked on the midpoint part. I would have done random stuff there and not gotten that.
Yeah, I would also have done just lengths, but then Kadab was like, these lengths are actually nice.
I would have buried that part. Like I'm not lying. I'm being
Yes.
serious right now. I would have definitely buried that. I would have like, okay, this is doable now, so I will do it.
Oh, also hello Sunan. Okay. There is a slight lag, but we will ignore.
Yes.
Where is Sunil?
Huh? In the chat.
Oh,
Okay, so that concludes this. I
That
guess.
I don't like P3. It worked out, but this is so scam. Like
I kind
this
of like it.
entire
I
thing.
mean, I guess it's nice enough. Like it makes sense why it's on the paper.
Hmm.
It's not too bad.
Yeah. I just don't like the solution. Like you're giving so much freedom, but like you just needed 2 strings.
Yeah.
The question is, can you just get those 2 strings?
Two strings is just to symbolize.
Like if you don't, okay, I don't think I would have
And then
seen
there's
this.
the random fact that 000 by themselves are insufficient.
Yes,
Like those guys.
that's just
That just
it just feels so
shaves off
lucky.
that one, right? That one extra one you would have had by the normal complement pairing. It just removes that one. And it
yeah.
gets you a nice answer.
This is just so much luck.
Yeah.
This is a problem.
Yes.
The complement
Totally
idea is so nice though. Like you either see it or you just die. Like maybe there's other ways to do this, but
I don't
honestly
think so.
doubt. Because
I think this is it.
Complement is just too much. Complement is on another level.
complement is just smart.
I guess you can kind of, because you get 2 to the k minus 1, you can kind of think about it. maybe.
Like you can think of a million things with 2 to the k minus 1. Like why? Okay, complement is fairly not very natural. to do.
Symmetric.
Okay.
Really?
Wait. No, this is dumb. There's a very easy explanation for why it works. See,
Why?
basically, like, yeah, just do this. So basically, you have whatever.
Where are you writing?
No, I'm not, okay. I started writing on my copy. Not used to this. Let's. Okay. Yes. There's a very easy proof for why this is exactly working because, yeah, like let's say the string is what? String is, let's say, A1, A2, AN, right?
Yeah.
AK, and each AI is in 0, 1.
Huh.
You're just assigning AJ, AI plus AJ mod 2, right? That's all you're doing. That's it, done.
Yes.
That's exactly what you're doing. And then this just works. This is like dumb. This is why it's working.
Oh.
Right? Because AJ mod, when you
I
add
see.
AJ mod 2 to everybody,
Just
it's adding
adding a one.
first
I
or
see.
keep it the same. And then that's just done.
But this isn't, I feel like this is maybe more confusing.
Is it confusing? It makes so much sense. This makes more sense than whatever random argument you're doing.
It's not that random. Like the point is
It's just
that
symmetric.
it's
Yeah,
symmetric.
this is symmetric.
So
It
it
is.
just work out because you're just reversing it.
Yeah.
I
No, and you're reversing if and only if AJ is 0 or 1, right? So based on that, this fixes all of them.
like the way you wrote it is neater, but how?
I feel like it's harder to
It's
see
the
from
same thing.
Yeah, it's harder to see. Like I would not see this.
No, this makes more sense. What?
the other one is literally just like
You just
put the
look
strings
at
on
it
this
and
one.
it's just working because it's shifting by the right thing.
Yeah, I mean, I guess that is true.
It's cool.
Just how did you have enough faith that symmetric would work out?
Yeah, I don't understand how
How did
anybody
you-
would.
Yeah, symmetric.
God
I
believes in
didn't have
God.
faith. I didn't have
I
faith.
mean-
God believes in God.
I was just looking at this random 6-digit string and I was like, let's try symmetric. And like, I have a very bad record of thinking simple. Like, I think there was some NT problem where I wanted the order to be small and the solution is just pick order to be 1. And like, I was just trying to show that you can make orders small. So I was just like, what if you're just like 2 strings and does that work? And it worked out there. The Siddharth was like, oh, inverse.
So do we write up the solutions?
Sure, fine. I mean, we can probably do that after stream. But
Yes. we should. Yeah, because like for the geos, maybe you would want to include a nice diagram.
maybe
Right?
you would want to include a nice diagram.
So, I mean, obviously,
I don't
would
like.
want-
I can't do asymptote. I'd probably just put a bad GCP diagram.
asymptote is
Okay.
easy.
Also,
Convert from-
if any of you have any questions about our solutions, or
Oh
stuff,
yeah,
you
that
can-
would make sense.
otherwise we'll likely be ending the stream sometime soon. So
Yes.
we'll just wait for a couple of minutes in case.
Wait,
people-
let me open YouTube as well.
Complement idea without justification is 3 marks. Okay, I mean,
What?
makes sense. It's not that hard to show it works. But you're not getting. Oh, that's
How did you? Oh, who wrote that?
Sunana said in chat.
Wait, why is it only 3 marks? That construction is the hardest part, no?
Yeah, actually,
No,
I agree.
construction is
Maybe we
fairly
should give
easy.
like 6
Once you
points.
get complement idea, you can write it algebraically and it makes sense.
I mean, you can draw it and you're like, see, this works.
Yeah.
I
This
guess
is
the other
weird.
side isn't trivial either. Yeah.
Which one?
Like bounding
Oh,
the
all
other
three.
side.
We realize you scammed in P1. What did you do in P1?
What do we do?
Sunana said. She bet we completed this in 1.5 hours.
No, you are wrong.
I mean, she was right.
Who?
One.
She thought we do it in 1.5 hours. We did.
We didn't.
We did.
No, we did it faster.
Within 1.5 hours.
Yeah.
Okay. We'll just wait for a couple more minutes in case someone has questions. Although there's only like 8 to few.
P3 and P6 are both quite hard though. I think we just got lucky.
Yeah. P6 was not that hard.
P6 was much easier than P3.
Yeah, P3 is very tricky. Like, if you don't see complement, like even think of symmetric idea, you're dead.
Yeah, I don't know how you would have the faith to think only symmetric.
Yeah,
I
like.
didn't-
Also, I guess if you have this time after P1 to just try and
Yeah.
just have faith and it'll work. Maybe. I don't know.
yeah, it is kind of only 2 strings.
Is that 2 strings is just a stretch? You're like K, 2K. Like even the jump from 2K to K when you said symmetric felt like a bit much. But
Just to complement that.
yeah.
But I can't find the
P3 is like most hit or miss I've seen recently. Okay, I've seen worse, but it's still, this is
Yeah.
hard.
Why you guys think P6 is easy? I don't.
P6 is easy after inversion.
Yeah, but
But nobody
how do you
will
believe in
consider
the inversion?
nobody believes in the inversion exactly. So that's why
It's not
Yeah.
that unnatural either. You have so terrible tangent circles and so nice incenter
Wait,
shots.
like it can't be all inversion, right? Like maybe let's just look at the thread.
There's non-inverse solution.
common app.
Common, yes, when I was applying for college.
Common.
Yes.
There should be a collection now.
Just
You
do
only
GGI.
tried
No, that
symmetric.
should pull it.
How much is only symmetric worth? I'd imagine quite a lot still. Oh, they're not checking it.
What?
I don't know why symmetric is not worth one.
I can understand if you only gave the construction.
Let's
maybe
check
like
the solution if
4.
P6. Has anyone come up with the inversive solution? Oh wow, that seems smart. I have no idea what that is, but it's probably some smart project.
I am.
I mean, it makes sense because if you have midpoints in the inverted
synthetic
diagram,
is even easier than your inversion, Archit.
no. If you have obviously,
Archit,
if you have
synthetic is easier.
okay, if you have midpoints in the inverted diagram, then you must have symmetrical structure in the original diagram. So that's cross
No.
chasing. That is probably what happened.
It's even easier. Like, okay, why it's not even this. Like you
How
have
did you
these
hit this
midpoints.
first?
Like you have this SC here, right? And you have this SB here, and you have
Yeah.
those circles. So this tangent here intersection this tangent here. Let's say some point X.
Oh, that's through 80. Oh yeah, that passes through 80.
That lies on radical axis, and it lies on 80. You just want to show 80 SB SC harmonic, which is true by projecting across I. It goes to BC and to midpoint of X. Okay, like if you just look for a third point on radical axis, it would have. Like, okay, it's not that bad even without inversion. Yes, Malay is saying there are non-inversive solutions. Did anyone do inversion though? Let's check.
I don't think anyone would have believed in the inversion.
This inversion? No.
So, nobody believes in inversion.
Yes.
Someone did inversion.
Yes, root BC inversion. Very good.
Fine.
10 out of
0.5. Wow, I've never seen anyone say 0.5 in angle.
Interesting.
Yeah. Okay. Oh, Aryan. Okay,
Wow.
but Aryan did synthetic.
That looks fast.
It's the same. Yeah, okay, fine. Do you want to just look at the threads of other ones in case there
Yes.
are other things?
Let's check solutions.
Problem
Everyone
one.
should probably have the same solution. Yeah, it's the same solution everywhere.
Yeah.
Oh, see, there's, I think, a summation solution. Go down. Yeah, I told you some type of global sum could work.
BI plus.
I literally told you this could work. You didn't believe me.
I mean,
Some global sum.
It looked ugly. This
I
looks ugly.
suggested Abhishek, but this is still not bad.
And this is CS.
I mean, you have
Okay,
a
fine.
bad that the only best part.
By the way, once you get BI equal to BJ,
Fine,
BI. Oh, bro, we could have finished much faster, right?
We finished fast enough.
No. Once you have BI equal to BJ equal to 2, BI greater than equal to BJ, and BJ greater than equal to BI. So AI equal to AJ, max is main and done.
No, you don't.
Oh,
get,
true.
No, that's not true.
you don't get. You get.
Oh, they only have one
Max's
direction. They only
neighbors.
got one direction.
You get Max's neighbors.
They only said, oh, if and only if. Achha, fine.
If and only if.
Yeah.
Okay.
Okay, that was just dumb. Why did we have to do the spreading out idea? There's no reason.
The spreading out sounds nice. Really good.
Yes.
AMGM. What are people doing? Maximum stuff. Come on. Problem 2. Like this has to be a known problem. So somehow
Yeah.
harder than P6 by a little bit. Interesting.
I
Meaning
think
this
they
is
took it from the
too.
Sophie mock.
It from Sophie Mock, yes. Oh, we didn't make this mock public. Only 1 to 4 are public. This is 6.
I think there is more in this configuration than you can initially see, because like if you consider AKL intersection ABC, then there's a spiral sim mapping the AEF to ABC, obviously, and then not AEF to ABC, but rather the circle to the other circle, and then you can get more stuff from that.
Oh, ARMO 2013. Interesting.
What is ARMO? All Russian. Makes sense.
Lines B and C. Point.
So they basically just copied.
They're exactly the same.
Oh wait, we've done this. We've done this problem. Yes.
I used complex number bashing. Who is that guy? Give him an upvote from my side, please.
Where?
Give him an
I-
upvote. Yes, just give him.
Okay, it's the same problem, but it's a different frame of reference. They took AKL as reference, and they said take tangents and drop perpendicular. Oh, is this the one where there's that Varenier parallelogram or something by the ultimate 1, 2, 3?
Alternate segment theorem. What is that?
Okay, it's that. If you have tangent, then that angle is that.
What?
That's called alternate segment theory.
What
Clearly,
is
you
called
did
alternate segment theorem?
you have a line, a tangent to a circle. Then this angle here is equal to that angle.
Oh, that's called, okay, interesting. I did not know it was called that. I just used this, I just remember it
Alternate
as the
interior
tangency
angles.
thing.
Okay, but yes, it's although like a very quick complex fashion.
Yes. I mean, you have to love these guys. Like,
Oh, Malay had a solution from 4 hours ago, I guess. What? No, this will be Rick wrote. I'm not even. Problem 3, pi r square. Oh, the pi r square. Complex. Same.
Exactly AI plus agent.
Oh, AI
it's
plus
the
AJ.
same solution. Oh, yeah,
This
yeah,
is so unmotivated. No one thinks AI plus AJ. Like he
you
just
can
gives
name it that way. That's what I said.
That sounds even cooler. Like that sounds
It
even more
sounds
magical.
cooler, but no one thinks AI plus AJ. You just like
Yeah.
look at it. First we claim either X inverse. Oh, he said inverse.
Why is it mathcality? That just looks super fancy.
I agree. I approve of mathcality.
That's not mathcal, that's math BB. Mathcal would give the more
Oh, it gives the curly.
planted version. Yeah.
We claim C equals to same.
Yeah, same thing. Yeah, just keep.
Oh, half 1 by 4, 1 by 2.
Quarter.
This doesn't.
Product across every point except some interval. Yes. Next number will be the distance from it.
No, he's just doing a complicated solution.
Yeah, this looks a bit
It's
complicated.
probably the same thing at the end.
No, I mean he eventually covers everything except a quarter circle, and then he does some stuff which I don't understand. Okay, I think looks like he's just doing half alpha after doing the thing.
Yeah.
Not sure.
I mean, he is making him move alpha at some point. Whatever.
Yeah. Twist or twist plus
5. 5 is a cute problem.
Yes.
yes plus B. Yeah, fine. And 6 we just saw.
Yeah.
6 is nice.
Was it?
It's a geo. We were able to solve it. Let's
Someone
call
says
it
a
nice.
familiar point. Why is that point familiar? The point T?
Mixed linear. Huh? It's familiar. Huh? It's a nice guy. Like,
Yeah.
okay, let's just see if anyone has any questions. Otherwise, we can probably end the stream.
Yeah, we can end the session.
Yes.
So should I stop the stream?
Yeah, I mean, yeah.
One was in here the entire time.
I didn't tell us.
I am stopping it. Just a second.
I'll stop the shadows.
Yeah.